Hello. This class is on latency. We will have learning objectives, why do you need it, exercises, learning verification, and a summary. Learning objectives. What kind of delay is repaired by QoS? What kind of delay is firewalls, antivirus, logging? What kind of delay is most often encountered? What kind of delay is certificate validation? What kind of delay is TFTP as compared to FTP? Okay, why do you need it? Well, latency is a fact of life. There are things you can do to try to work around it, but we don't yet have internet faster than the speed of light. I know there's some research in this area, but I don't yet have that kind of internet. So, okay, now different kinds of delay. What kinds of delay can be experienced on a network? Well, we have 5 basic types here. There's distance, there's queuing, there's transmission, there's processing, and there's implementation. For distance, it basically means the further you go, the longer it takes. Queuing, you should be able to understand that it basically means you're standing in line. For transmission, different media have different traits. Processing, it takes the CPU a certain amount of time. Implementation, doing things the slow way or the fast way. Or not necessarily even the slow way or the fast way, but maybe one way is less efficient and maybe another way is more efficient. Now, how can you minimize distance delay? Well, you'd have to take a shorter path. That's how you would minimize distance delay. Okay, how could you minimize queuing delay? Well, you could make multiple lanes, and then you could put priority traffic in an express lane. Please note, if everything uses the multiple lanes, you're back where you started. See traffic jams. How can you minimize transmission delay? Well, instead of using a pothole gravel road, you could use a paved highway. Better yet, use a helicopter or a jet plane. Please note, now better transmission media have a habit of being more expensive. How can you minimize processing delay? Well, simple. You get more processing power. You trade in that Pentium 2 for a Pentium 4. Hopefully you youngins can get that one. All right, how can you minimize implementation delay? Well, in this case, you would choose a faster method. For example, instead of counting by ones, try counting by fives. Okay, now what's the most common type of delay? Distance. Distance is the most common type of delay. So, what is the speed of light problem in networking? I don't know if it's necessarily a problem, but basically, light can only travel so fast, and likewise, telecommunication signals cannot exceed the speed of light. This basically means that the further things are apart, the longer they will take. It should be noted there may be some research going on in this area, but I don't yet have a practical means of taking advantage of it. You know, so-called quantum communications. Okay, now learning verification. What kind of delay is repaired by QoS? What kind of delay is firewalls, antivirus, logging? What kind of delay is most often encountered? What kind of delay is certificate validation? What kind of delay is TFTP as compared to FTP? So, QoS, which is known as quality of service, actually works on queuing delay. So, if you had a case where the queue is being clogged up, you could create a separate, express lane, or sometimes it's called priority queue, but you separate traffic out, similar to on a road where, you get the ambulance or the fire truck, it turns on the lights, say, hey, I'm special, let me through, express, and everyone moves over to the right and they stay in the right lane, and then the priority traffic will take the fast lane. And that's basically what QoS, a lot of QoS features basically do something similar to that. They try to address this queuing delay in general. So just keep that in mind. So if your delay is actually based on distance, QoS won't necessarily help you, is what I'm trying to get at. So keep that in mind, what your actual source of your delay is before you try to, apply a solution. Now, there's firewalls, antivirus, and logging can add processing delay because now you have to use up those CPU cycles to provide this additional processing. This can especially sometimes impact your host. Or if you're actually running these features across the network, these are things you have to consider, that the more features you're turning on, the more resources it's going to take. Now, there are actually some platforms that are optimized to provide minimal delay while still providing all these features. Now, distance delay is most often encountered. Now, certificate validation can be a combination of processing, implementation, and distance delay. It can be a distance delay issue if the certificate has to be validated against something that's far away. So it has to travel that distance. Also, it could be implementation in case, things were implemented poorly or they were implemented to use the slower method. Say the implementation relies on certificate revocation lists, which are files that must be downloaded, versus using an online, certificate status protocol server to just check that online and get that status result a lot more efficiently than downloading an entire certificate revocation list. It also could be processing because now the system has to process all this additional information. Now, compared to FTP, TFTP is implementation delay. The reason why is TFTP will not be able to necessarily perform a good solid stream or chunking of data. TFTP actually wants an acknowledgement for every single bit of data it sends across. It'll say, I sent this block, okay, let me acknowledge this block. Okay, I sent this block, let me acknowledge this block. I sent this block, let me acknowledge this block. Now, there were some modifications to TFTP to allow a slightly larger block size, but it still is nowhere near as efficient as FTP for the transfer of data. And the actual difference in how these are implemented is most apparent if you compare their performance across a wide area network when you introduce distance delay to the equation. Then the differences between FTP and TFTP will be more apparent. And you will notice that FTP will be able to have a much better performance in a wide area network scenario than TFTP will. Okay, so that concludes today's lesson about latency. I hope you had fun. Thank you very much.